हेलो स्टूडेंट्स, आज हम लोग पढ़ेंगे रॉड्रिक्स फार्मूला फॉर लैगेरे पॉलिनोमियल। तो आज हम लोगों को प्रूव करना है दैट ln x is equals to e to the power x factorial n and nth derivative of x to the power n e to the power minus x. So this is a function of u into v and we have to find the nth derivative of this function. For this we can apply the Leibniz rule, the Leibniz theorem for differentiation, which we have studied in our previous classes, which is u into v, the nth derivative of any two functions, product of two functions, which is in the form u into v is nc0 nth derivative of u and 0th derivative of v. मतलब u वाले फंक्शन को n टाइम्स सक्सेसिवली डिफरेंशिएट करेंगे और v वाला फंक्शन हमारा एज इट इज रहेगा. आफ्टर दैट nc1 u वाले फंक्शन को n-1 बार सक्सेसिव डिफरेंशिएशन, v वाला 1 टाइम्स डिफरेंशिएशन, nc2 u वाला n-2 टाइम्स डिफरेंशिएट and v 2 times differentiate and so on. So taking the RHS part of this, that is e to the power x factorial and nth derivative of x to the power n and e to the power minus x, we will apply Leibniz theorem for differentiation, the nth differentiation. तो इसमें हम लोग u मान लेते हैं e to the power minus x को और v मान लेते हैं x to the power n को, और अब हम लोग Leibniz theorem अप्लाई करेंगे और उसको डिफरेंशिएट करेंगे. तो ये e to the power x और फैक्टोरियल n हमारा एज इट इज उतर के आएगा. ये x to the power n ये हमारा v था, तो ये ऐसे ही उतर के आया क्योंकि v को हमको 0 बार डिफरेंशिएट करना है और u को हमको n बार डिफरेंशिएट. तो इसका जब हम सक्सेसिव डिफरेंशिएशन करेंगे तो ये हमारा -1 टू द पावर n e टू द पावर माइनस x आएगा. द नेक्स्ट वन nc1 देन u इज बीइंग डिफरेंशिएटेड n-1 टाइम्स. सो n-1th डिफरेंशिएशन ऑफ e टू द पावर माइनस x विल गिव -1 टू द पावर n-1 e टू द पावर माइनस x and v is being differentiated 1 times. तो इसका एक बार डिफरेंशिएशन करेंगे x to the power n का, तो ये nx n-1. Similarly nc2 u is being differentiated n-2 times, so e to the power minus x will be differentiated n-2 times, which will give -1 to the power n-2 e to the power minus x, and v, that is x to the power n, will be differentiated twice and this will give n-1 x to the power n-2, and continuing in this process we will get lastly x to the power ncn e to the power minus x factorial n, which is our last term, because u is being differentiated 0 times, so this will be written as it is, and the nth derivative of v is taken, so the v is x to the power n and its successive differentiation, the nth differentiation of x to the power n will give factorial n. This is by using Leibniz theorem. Now our next step is to take out the common factor, that is e to the power minus x, from each of our terms. Taking e to the power minus x common, we get the simplified expression as -1 to the power n x to the power n. This is nc1, the value will be n, and this is one more n, x to the power n-1 -1 to the power n-1, and e to the power minus x is being taken common outside. Similarly nc2 will give n-1 by factorial 2. This is n-1 again, and x to the power n-2, -1 to the power n-2, and e to the power minus x is again are outside. So this is our whole expression. From the last term, ncn will give the value 1. This is factorial n, and this is again the common factor. So this is our simplified expression. Now this cancels out, e to the power x and e to the power minus x. What remains is this term. So we will multiply and divide each of the terms by factorial n. Numerator and denominator of each of these terms are multiplied by factorial n, and we have one more factorial n, and so factorial n is divided and multiplied by each of the terms to the numerator and denominator, and the one factorial n which lies outside is again multiplied. So we get the expression as this, because see, 2 factorial n will come here, so this becomes factorial n square, and 1 factorial which is multiplied to the numerator will come over here. Similarly, when we will multiply it by factorial n and factorial n, so this factorial n can be written as n into n-1 factorial, and this n cancels out, and this again factorial n, when it comes in, it can be again written as n-1 factorial. So this again comes out, so this becomes n-1 factorial square, which we get in our next term. Similarly, we can proceed and we get it as in this way. Now when summarizing the overall term, what we see that we get -1 to the power r as our generalized expansion factorial n factorial r square for this, and n square factorial n minus 1 square factorial n minus 2 square. So this is written as factorial r square, and this again factorial n minus r, which goes as 0 factorial 1 factorial 2 factorial n minus 1 factorial. So this is what our ln x is. So ln x is equals to our term which we had started with, that is e to the power x factorial n, and then differentiation of x to the power n e to the power minus x. This is what Rodrigues formula is.